In the quiet, predictable ballet of celestial bodies, one object has suddenly broken the rhythm almost as if it's performing a routine choreographed by a different universe entirely. That object is 3I, Atlas, an interstellar visitor that seems intent on rewriting the rulebook of comet behavior. For centuries, astronomers have confidently relied on a simple, irrefutable formula. The closer a comet gets to the sun, the more active it becomes. Ice heats, evaporates, and forms the iconic glowing coma and tail. Move away from the sun, and the activity dies down. It's a law as trustworthy as sunrise, but 3I, Atlas, it's refusing to obey. Even at distances where water ice should freeze into complete silence, 3I, Atlas is alive, bright, noisy, ejecting material like it's basking in solar fire. It's not just unexpected, it's unnerving. It's not just an oddity, it's a cosmic confrontation with everything we thought we knew about comets. Something is keeping 3I, Atlas, awake. Something hidden, maybe something never seen before. This isn't a minor glitch. This is not a small deviation that can be brushed off as observational error or a glitch in thermal modeling. This is sustained activity measured, confirmed, and increasingly mysterious occurring in an environment where silence should reign. To put this into perspective, imagine a frozen lake suddenly steaming in the dead of winter, under a sky of ice. You start questioning the physics you trusted all your life. That's exactly how astronomers feel right now. Their carefully crafted models not only fail to explain the brightening of 3I, at last they completely break down in its presence. The comet moves farther from the sun, yet grows more active, as if the darkness itself is energizing it. If this was happening to one of our local comets, we suspect a miscalculation. But this is no ordinary comet. This is only the third interstellar object ever discovered and already. It's forcing a rewrite of the story of how comets live, die, and behave. The question haunting scientists right now is simple. Why? Let's break it down. Standard comet models are built on the assumption that water ice is the main driver of a comet's activity. When a comet gets closer than about 2.5 astronomical units, AU, that's roughly the distance between the Sun and Mars, water begins to sublimate. Boom, coma and tail appear. Move farther, temperatures drop. Water ice refreezes. The fireworks stop. But 3I, Atlas, is beyond 3AU. It's receding, and yet it continues to release gas and dust at a rate not just detectable, but almost impossible to ignore. This means one of two shocking possibilities. Either 3I, Atlas, is made of something fundamentally different from the comets in our solar neighborhood, or something completely new is going on inside it. Scientists are split. Is it chemical? Structural? A new form of ice? A cosmic mechanism we've never even theorized? All roads lead to the same unsettling thought arc. Understanding of cometary physics may be permanently incomplete. The iceberg is larger, stranger, and much darker than we ever imagined. So what could be powering this defiant brightness, this off-script eruption of energy in the cold vacuum of space? One of the strongest theories centers around hypervolatile ices, materials like carbon dioxide or carbon monoxide, which sublimate at far lower temperatures than water. If 3I Atlas is rich in these exotic ices, they could be evaporating even at the frigid distance of 3AU, producing a coma and tail that shouldn't exist by water-based logic alone. But even that doesn't fully fit the tale. The activity level is unusually high, too high, for a simple carbon dioxide explanation. Are other, more exotic ices involved? Is there a strange structural mechanism amplifying the heat from the sun? Could ancient cosmic radiation have left 3I, Atlas, riddled with channels that now efficiently vent gas trap for millions of years? Every answer creates more questions. Every measurement reveals more contradiction. What we're looking at isn't just a dirty snowball from another star. It might be a message written in ice and shadow a chemical time capsule from a place we can never visit. This isn't the first interstellar visitor we've encountered. You might remember one eye, Oumuamua, long, cigar-shaped object that zipped through our solar system without developing a visible tail, yet mysteriously accelerated. It sparked theories that still ripple through astrophysics, from outgassing hydrogen to alien technology. Then came 2I Borisov, a more conventional comet, behaving in ways we've seen before, driven by water ice, predictable, almost comforting. And now 3I Atlas arrives, landing in the middle of those two extremes like a riddle on fire. It's clearly active, unlike Oumuamua, yet it's behaving unlike Borisov, defying solar system expectations like a rebel with a cosmic cause. Three objects, three impossibly different stories. If this is a pattern, then interstellar space is more diverse, more chaotic, and more creative than we ever imagined. The galaxy isn't just sending us visitors, it's delivering warnings. Our models, our expectations, our confidence, they're too small for a universe that refuses to repeat itself. Like a puzzle piece from a shattered mirror, 3I, Atlas reflects a reality we don't yet recognize. To unlock the mystery behind 3I Atlas, scientists are racing against time. Every passing day sends the comet farther from the sun, deeper into the blackness of interstellar space, where our best telescopes may never follow. Every second matters, but this isn't just a race against distance, it's a race against the limits of what our tools can observe and what our minds can accept. Researchers now rely on multi-technique analysis, photometry to track brightness, spectroscopy to hunt for chemical fingerprints, and high-resolution imaging to analyze the shape and size of the coma. Each measurement feeds into models that are already straining under the weight of contradiction. If the production rate of gas matches carbon dioxide sublimation, and if water remains silent, that's a clue. But if we detect carbon monoxide at massive levels, that's revolutionary. Somewhere out there, beyond the glow of the sun, lies the answer. Atlas isn't just testing our instruments, it's testing our philosophy. Yet the puzzle lies deeper than composition alone. Even if 3I, Atlas, is rich in hypervolatiles, why is the activity this intense? The answer may lie beneath the surface and the bones of the comet itself. Some scientists now speculate that this object may be extremely porous, more like a fragile cosmic sponge than a compact ice ball. If the nucleus is riddled with cracks, cavities, and ancient thermal scars, sunlight doesn't just warm the outer skin, it seeps deep into the core, igniting unseen deposits of volatile ice. Instead of activity being limited to a thin surface layer, sublimation could be erupting from the inside out, venting through networks of microscopic tunnels. The result? A far more dramatic, sustained release of gas and dust, far beyond what classical comet structures can manage. In a way, 3I, Atlas, could be broadcasting its inner chaos into space, a slow-motion exhale of the turbulent conditions it experienced in places beyond our star. If that's true, then we're not just watching a comet, we're watching cosmic history unravel in real time. But here's where the story gets even darker. What if this porous interior isn't a result of natural processes alone? What if something in the depths of interstellar space damaged 3I, Atlas, in ways our local comets never experienced? Imagine millions of years of exposure to cosmic radiation, micrometeoroid impacts, or volatile cosmic dust storms. Over time, ice may have fractured, turned brittle, become layered like shattered glass. If every interstellar comet carries battle scars from a different cosmic war, then each one that enters our solar system is a time capsule, a messenger containing the violent history of a star system we've never seen. 3I, Atlas, then, is not a typical comet, it's a survivor. A relic, a wanderer that has passed through nightmarish conditions we can barely comprehend. The activity we see today could be the last gasp of a body that has been losing pieces of itself for eons. What happens when those pieces finally dissolve? Will we have learned enough by then? Think about what all of this means. If 3I, Atlas is shattering our models not because our physics is wrong, but because our sample size has been too small, then everything changes. Every interstellar object could be its own category, its own story, its own little universe of chemistry and structure. There is no average interstellar comet. There is no standard. With just 3 objects, Oumuamua, Borisov, and now 3I, at last, we've already seen 3 radically different outcomes. What happens when we've observed 100, 1,000? How many new rules will we need? How many old ones will burn? The thought is terrifying and thrilling. 3I, Atlas isn't just asking us to update a few equations. It's telling us that the universe is writing chapters of science we haven't even opened yet. Maybe this is just the beginning of a revolution in cosmic chemistry. Maybe the galaxy is filled with secrets more shocking than any fiction. But don't mistake this as a purely academic exercise. What we learn from 3I, Atlas, will change the way we prepare for future interstellar Encounter 7 potential hazards. Every comet passing near our sun leaves a trail of clues. But interstellar comets carry the fingerprints of alien formation zones disks around alien stars, with temperatures, pressures, and elemental ratios we've never seen. If some are hypervolatile time bombs, what would happen if one passed too close to Earth? What if an object like 3I, Atlas, didn't just play by different rules, but brought with it materials or reactions we weren't ready for? Understanding composition isn't just about curiosity, it's about readiness. It's about learning what the universe is capable of throwing our way. And right now, 3I, Atlas, is throwing us a curveball that bends the laws we've lived by. The question is no longer whether our models will change, but how much we're willing to change for the truth. Space, for all of its silent emptiness, has a strange way of surprising us. Just when humanity thinks it has mapped its mysteries, something unexpected appears, something that rewrites everything we thought we knew. Recently, astronomers around the world have turned their attention to a mysterious object drifting through our solar system. Not a comet, not an asteroid, and unlike anything ever documented before. It isn't losing material. It isn't spinning chaotically like a broken rock. It looks deliberate, steady, controlled. This isn't just cosmic debris wandering aimlessly. It's as though something or someone is piloting it. And the strangest part? It's coming closer. Scientists are struggling to categorize it. Journalists are avoiding it. Government agencies are whispering behind closed doors. Because if this isn't a natural object, then we may not be alone, and that changes everything. If you're watching this, prepare yourself. The story you're about to hear might be the beginning of the greatest discovery, the greatest threat in human history. It all began with a faint, unassuming signal picked up by the Pan-STARRS telescope in Hawaii. At first, the object, designated simply as 3I, Atlas, appeared Boringan icy wanderer moving from star to star. But when scientists ran detailed scans, the data told a different story. There was no coma, no tail, nothing that comets typically emit when heated by a star. Instead, this object reflected sunlight like metal, smooth, polished, engineered. That was the first hint. The second? Its trajectory. Instead of the expected curved path caused by gravitational influence, it moved in a near-perfect straight line. That isn't just unusual, it's impossible under normal laws of physics. Even more chilling is that its speed doesn't match what gravity alone can explain. It accelerates subtly, but undeniably as if powered. Some say it's just an interstellar rock. Others whisper it's a probe, a visitor, a message. Whatever it is, humanity is suddenly faced with a question we've long avoided. What if we are not the first civilization to reach this point? The deeper scientists dig, the harder it becomes to dismiss the unsettling nature of 3I Atlas. Usually, space objects are easy to track, predictable, slow, apathetic. But this one, it seems almost aware. Observatories in Europe reported that during a brief period, the object adjusted its course slightly, moving away from a cluster of space debris. That single deviation sent shockwaves through the scientific community. What celestial body avoids collisions on its own? Suddenly, 3I, Atlas wasn't just an objective, was a mystery wrapped in technological precision. SETI, the search for extraterrestrial intelligence, reactivated dormant antennas. The Pentagon issued classified memos, and NASA scheduled a meeting with international partners with one cryptic note: prepare contingencies. Meanwhile, internet forums buzz with theories. Was it an abandoned alien ship drifting through eternity, a survey craft, a cosmic warning, or worse, an advanced scout? The unknown isn't just in the sky now. It's in our minds, pushing against the fragile walls of everything we believe is true. Governments don't panic easily, at least not publicly. But behind the scenes, old Cold War reflexes are starting to awaken. Leaked emails suggest that two powerful nations have already begun debating whether to intercept 3I, Atlas. Not to study it, but to stop it. Because what if this isn't an accident? What if this object, with its silent approach and unnatural precision, has a purpose? What if its arrival isn't random but calculated? Every telescope turned toward 3I, Atlas brings updates that are as mesmerizing as they are terrifying. Its surface reflects wavelengths no known rock should. Its movement is eerily stable, like something designed to endure. And the timing its entry into our solar system at a moment when we are technologically capable of detecting it feels intentional. If it's a message, what does it say? If it's a machine, who built it? Every answer leads to more questions, and one truth becomes harder and harder to ignore. Something is coming, and we are not ready. As we draw closer to the moment when 3I, Atlas will pass within reach of our instruments, the world is splitting into two divided states of mind. One side clings to hope, dreaming of first contact, a civilization beyond our own, more advanced, perhaps kinder. The other steps into fear, warning of silent invasions, ancient warnings, and consequences we are unprepared to face. Meanwhile, scientists insist on one chilling fact. This object is unlike anything nature could produce. It's empty of gases, resistant to solar radiation, and projected to maintain its structure even after its closest approach to the sun. That defies physics, defies logic unless is built to survive, to endure. As the countdown continues, the world's leaders gather in secret. Audiences wait with unanswered questions, and you watching this now need to decide whether to feel wonder or dread. Because what comes next might define the future of humanity for ever time.